Greetings and salutations, everyone. We are a team from VIT Chennai, Electronics and Communications Branch, batch 2019, and our project ID is PF2. Our project domain is Flexible and Variable Electronics, and our project idea is loop based AMC for gain enhancement of wireless antenna. The team members are Aman Sahu and me, P. Uday Bhaskar. Our guide is Dr. Ravi Prakash Dwivedi sir, and our co guide is Dr. Lucky Agarwal sir. Coming to the motivation. In today's world, as we can evidently see that there is a major shift from wired media to wireless. And when we talk about wireless transmission, the first thing that comes to mind is an antenna. Now, talking about antenna, not a lot of research has been done on AMCs, which can make antennas a lot more compact and efficient. So we aim to design an antenna which is cost friendly, but at the same time completely efficient. And also with technologies like IoT, wearable devices, 5G communication, the need for compact, low profile, and flexible antennas is on an all time high.
Novelty. We tried to implement a square loop based AMC under microstrip patch antenna, which is relatively not much explored. We are using metamaterial approach using square loop AMC substrate to increase the gain of the compact antenna. Also using a microstrip patch antenna with AMC would make the antenna design relatively easier and cost efficient. Also, the proposed antenna design could be a lot useful in 5G communication. Next slide. Introduction. An antenna is a transducer which converts electrical power into electromagnetic waves and vice versa. An antenna can be used either as a transmitting antenna or a receiving antenna. The microstrip patch antenna are low profile and low cost. Also easy to fabricate, modify and customize. A metal patch mounted on a dielectric substrate material with a metal ground. Artificial magnetic conductor AMC is a metamaterial which is widely used nowadays in antenna design. AMC mimics the behavior of perfect magnetic conductor which is not available in nature. With the incorporation of AMC to antenna design, various performance of the antenna can be improved.
Okay, so the tools used in our project is the software called ANSYS HFSS. It is a high frequency structure simulator that can be used to design and simulate high frequency electronic items. This includes antennas, antenna arrays, RF or microwave components, high speed interconnects, filters, connectors, IC packages, and PCBs. Now, coming to the main antenna design, the suggested insert fed rectangular microstrip patch antenna, whose dimension parameters are compiled in the given table, is shown in the top view in the adjacent figure for the frequency band of the center frequency of 3.5 gigahertz. So the operation frequency of our antenna is 3.5 gigahertz, and the thickness of the antenna is around 1.6 millimeter. And the substrate that we used is a polyester substrate which is flexible, and the antenna patches are all being printed on a polyester substrate which would be copper. So this is the antenna design, the bottom view, top view, and the isometric view.
AMC unit cell design. A square ring of 13.7 cross 13.7 is placed over a polystyrene substrate whose dimensions are 15.7 cross 15.7 with a thickness of 3.2 mm is treated as unit cell when it is grounded by a perfect electric conductor. Design of proposed antenna. This figure shows the final design of the suggested antenna backed by the AMC surface, which is 2 cross 2 array of unit cell. We found out the antenna and the AMC surface should be 17.9 mm, which is lambda by 4 distance from antenna and AMC surface. Finally, after varying the distance between the AMC surface and the antenna in order to find the better gain, we found H gap around 12 mm distance to be optimum, which where we got a good bandwidth while having a increment of gain 1.2 dB.
Now coming to the results and inference, a small flexible antenna is used at first. A square loop AMC surface is suggested to increase the antenna's gain. Finally, this part studies and elaborates on the AMC integrated antenna's performance. The final AMC ground size is chosen to be 2 cross 2 as it gave better results than 3 cross 2 ground size, 3 cross 3 ground size, as it is evident from the given return loss and gain graphs which are given in the right side of the slide. It was found out that the suggested AMC provided the maximum intensity for H gap of 12 mm. Thus, separating the antenna from the AMC, the separation of the antenna from the AMC is now fixed at around 12 millimeters. Figures demonstrate the gain variation for various H gap. The final gain obtained was 5.7 dB. The return loss was 23.5 dB. Bandwidth was 800 megahertz approximately. Now coming to the future work. In future work, we aim to reduce the overall size of the antenna even more. Also, we will try to increase the bandwidth and the gain of the antenna so that it can be used in even more applications that we will do by modifying the AMC surface. Also, we can try more flexible substrates and compare the present results with them. Finally, we are also looking forward to test the antenna in real time by fabricating it and testing it in the anechoic chamber which is present on our campus. Thank you.
Thank you.